Here we want to find Laplacian of fourth derivative of f of t. Solution. We shall use mathematical induction. For f second derivative of Laplacian, we'll generalize a relation for fourth derivative of Laplacian. How? We shall see in later steps. So first, we find Laplacian of first derivative of f of t. By definition, this is e power minus st f prime of t into dt, which equals, using u into v formula of integration, integration of f prime of t is f of t with limits from 0 to infinity minus derivative of e power minus st is minus s into e power minus st. Integration of f prime of t is again f of t and dt. Putting limit from 0 to infinity, e power minus s into infinity f of infinity minus e to the power minus s into 0 f of 0 minus minus plus, taking s outside the integral as s is independent of t. As derivative of function f of t exists, so f of t is finite, and f of putting x t equal infinity will again give a finite value. So this is finite value, and e to the power minus infinity is just 0. So this term will overall be 0. So this equals 0 minus e to the 0 is 1 and f of 0, and this over here is Laplacian of f of t plus s into Laplacian of f of t. This is Laplacian of first derivative of f of t. So this equals, rearranging, now we use Laplacian of f double prime of t is 0 to infinity e to the minus st f double prime of t dt. Equation A. We shall use this value of f prime of t later on in this integral. Using u into v formula again, we get integrating second function and putting limit from 0 to infinity minus taking derivative of first function and integrating second function into dt. We note value of this equation over here. So this, simplifying this, we get LF f double prime of t equals e to the minus infinity. F of t is finite, so its first derivative is also finite. So this value will give 0 into finite value 0 minus lower limit of integration is minus e to the 0 into f prime of 0 minus minus plus s, and this function over here this function is, this was f prime of t reducing one function. As integration reduces derivative by one order of 1, so integration of second derivative of f of t is of course f prime of t. this is minus 0, this is 0 minus 1 into f prime of 0 plus s into, this is Laplacian of f prime of t. We shall use this value of f prime of t in this equation. So minus f prime of 0 plus s into, use this value, Laplacian of f of t minus f of 0 s square into Laplacian of f of t minus s into f of 0. So this is Laplacian of second derivative of t, f of t. Rearranging, we get s square L of f of t minus s to the power 1 f of 0 and minus, this is f prime of 0. There is s to the power 0. Similarly, we can use this to find Laplacian of triple derivative of f of t is s cube of Laplacian of f of t minus s square of f of 0 minus s to the 1 f prime of 0 minus s to the 0 f double prime of 0. So this implies that Laplacian of fourth derivative of function f of t s to the 4 Laplacian of f of t minus s cube f of 0 minus s square, increasing power s by 1 because here one high derivative is taking place over here. So this is required relation for Laplacian of fourth derivative of function f of t.